In this video, we're going to talk about x and y intercepts. Now, an x-intercept of a graph is the x-coordinate of a point where the graph intersects the x-axis. And similarly, y-intercept of a graph is the y-coordinate of a point where the graph intersects the y-axis. Let's look at an example. The graph of y equals x squared minus 2x minus 8 is shown below. And this is the graph that we found in the previous video. As you can see, the 2 points where the graph crosses the x-axis or touches the x-axis are minus 2 comma 0 and 4 comma 0. So the x-intercepts are minus 2 and 4. Okay, the y-intercept of this graph is minus 8. Notice that's at the point 0 comma minus 8. That's where the graph crosses the y-axis. Now, one of the questions you might ask is, how do you find the x and y intercepts of a graph if you just have the equation for the graph and you don't actually have the drawing of the graph? To find the x-intercepts of the graph, you just set y equal to 0 and solve for x. And to find the y-intercepts of the graph of an equation, set x equal to 0 and solve for y. Now, why is that the case? Well, the x-intercepts always occur when the y-coordinate is 0. Okay, so if we let y be 0 and we try to solve for x, we find the two x-intercepts in this case. And to find the y-intercept, we let x be 0 because any y-intercept is going to be along the y-axis, and points along the y-axis have the x-coordinate being 0. So to find a y-intercept, you set x equal to 0 and solve for y. So let's actually do it for this particular equation. Find the x and y-intercepts of this. Now suppose we haven't seen the graph before. How do we find the x and y-intercepts? Well, to find the y-intercept or intercepts, you have to set x equal to 0, right? Set x equal to 0. And solve for y. So we have y equals 0 squared minus 2 times 0 minus 8. And notice that's 0 minus 0 minus 8. That is minus 8. So our y-intercept is minus 8. To find the x-intercepts, we have to set y equal to 0. In this case, we have 0 is equal to x squared minus 2x minus 8. And now we need to solve this for x. Now, there are a couple ways that we could solve this. We'll talk about this a little bit later. One way is to use the quadratic formula. But I think the easiest way is to factor this. Okay, so I'm assuming that you have seen factoring before. This will factor to x minus 4 times x plus 2, because x times x gives you x squared. Minus 4 times x is minus 4x, but then 2 times x is positive 2x. So if you have minus 4x plus 2x, you get minus 2x. And minus 4 times plus 2 is minus 8. So what values of x make this be 0? Okay, what values of x can you plug in that will make this be 0? Well, notice if you let x be 4, this will be 0. Okay, you'd have 0 times 6, but that would be 0. So x equals 4 is a solution. And what value of x would make this be 0? Well, if you plugged in minus 2 for x, this would be 0. So what you get is x equals minus 2 is the other solution. So notice our x-intercepts are minus 2 and 4, just like we had in the graph above. Let's do another example. This one's a little simpler. It doesn't involve any factoring. Find the x and y-intercepts of the graph of 2x minus 3y equals 12. And then graph the equation. Okay, we'll just draw a quick sketch of the graph. Now, if to find the y-intercept, again, you have to set x equal to 0. And if we do that, we get 2 times 0 minus 3 times y is equal to 12. So 2 times 0 is 0. We have minus 3y is equal to 12. If we divide both sides by minus 3, we get y is equal to negative 4. Okay, so the y-intercept is negative 4. The x-intercept, we set y equal to 0. And we have 2 times x minus 3 times 0 is equal to 12. We get 2x is equal to 12, so x is equal to 6. Okay, so the x-intercept is at 6. Okay, just as a quick graph, it turns out that the graph of this is actually linear. Okay, it's a straight line, but the x-intercept occurs over here at 6, and the y-intercept occurs actually down here at minus 4. And so the graph it turns out looks like this. Okay, again, how do I know it's a straight line? Well, we'll talk about that a little bit later.